Press the button. Okay. Hey, everybody. As always, please let me know if we exist. I require your confirmation. I'm hearing a little bit of an echo. I'm not sure whether that's coming from my streaming software or it's coming from your headphones. Have you got the video
From me?
playing somewhere? Yeah. No?
No, I'm all in headphones.
Okay, perfect.
Okay,
No,
it
it's
should be
good.
okay.
Hey, everyone. Welcome to a very special episode of Open Space. Later on, I know for some people that's awesome. For other people, you're asleep and you're going to have to catch this tomorrow. I apologize. And that's that's a good, sincere Canadian apology. I'm joined by Dr. Casey Hanmer, who is a theoretical physicist and works at NASA. Casey, welcome to Open Space.
Thank you. Great to be here.
So before we get into all of this, do you want to provide your your disclaimer?
My disclaimer.
Yeah.
I have no idea what I'm talking about. The the most important disclaimer is that NASA is a publicly funded institution, and I'm lucky to be employed there at JPL. And they encourage us to share our enthusiasm and our love for space and for science with the general public. In fact, it's part of NASA's mission, and so I'm kind of doing work this evening in a way. But at the same time, I have to be absolutely stringently clear that my views expressed tonight represent my own opinion, my own almost terrible opinions, and not official opinions of NASA or in any way. And NASA has an office full of professionals who do professional communications to make sure that NASA's official views are well understood. And you should refer to them or to the website if you want to get NASA's official view on anything.
Perfect. There. So NASA.
Great. So I'm going to say something cool.
Yeah, it's all my fault, not Casey's fault. If you have any concerns, just bring it all back to me. All right. I think I got the echo. If you're still hearing the echo, let me know. Yeah. Anyway. So Casey, what do you do? Who are you?
I'm a deeply confused physicist. I grew up in Australia, as you can probably tell from my accent. And as an Australian, Australia only got a space agency quite recently. It was always a dream of mine to work on space-related stuff, and over time that becomes subsumed into doing physics. And I got a PhD in physics, and then I realized, halfway through my PhD, which was at Caltech, that NASA was only a few miles away and SpaceX just across the other side of the city. And I decided that, while I was young and full of energy, I'd probably rather work on that. Thank you very much. And so I decided to switch careers for the second or third or fourth time. And after a few years in the wilderness, I'd worked on a bunch of different interesting things. Decided to was recruited at JPL. I work right now. I develop software, mostly for GPS and image processing systems. But I do a little bit of everything, and it's a lot of fun because it allows me to combine both software engineering, which is something that I'm still learning, and physics, which is something that I'm still learning, and combining them in ways to solve new and interesting problems every day.
So where you came across my radar, and I think you came across sort of many people's radar sort of all at the same time, was you wrote just a wonderful blog post on your personal blog, nothing to do with NASA, all about how you felt like people were really underestimating what the implications of Starship, and if not specifically Starship, but just this idea of reusable rocketry, where this takes humanity. So can you kind of give your, sort of a version of sort of, what you're presenting there?
Yeah, so I've been working on these blog topics on a variety of different things, and I was very pleasantly surprised to see my viewership climb by about a factor of 1,000. And I discovered a neat trick, which I think journalists have known for a long time, which is if you include the word Elon Musk in a blog post or an article enough, you will generate clicks. But I think it's also important to understand that in doing so, I tapped into a kind of vein of profound optimism amongst the space enthusiast public, which are people who have always been interested in space, going back to before the dawn of the space age, really, and really want to see a narrative that evokes expansive exploration, inclusive kind of narrative. That's something for everyone to do. They can get involved, they can hope, they can dream. And I think SpaceX has tapped into that incredibly effectively, possibly without even intending to, at least not in such a general way. I'm just every day I'm keeping track on what Starship is doing and what it's up to. One of the things that my physics background allows me to do is to essentially do the math on how well the Starship works and all this kind of stuff. And there's dozens of people out there who do basically the same thing, and you can find them on YouTube and you can find them on Twitter, and they do the same sort of calculations. And I feel like I'm like a kind of in the corner of the room in that group. But every now and then, someone has an interesting question and I can solve that problem. I write a little bit of code or whatever and solve that problem. And one of the things that I realized was that people were talking about Starship, in terms of the context of doing human exploration of the moon and Mars and deep space. And they weren't really understanding, despite, I'm just got a notification that my internet connection's unstable. So if I drop out, just kind of, I'll come back, I guess. People were really getting, even though Elon had talked about it, really like how different SpaceX's plans to use the Starship were from more traditional space exploration plans that you might have seen in movies like The Martian or the Mars Direct plan developed by Bob Zubrin and Dave Baker, or other things like that. And so I thought, well, this is a really great nexus to approach a blog post, because I can start up by explaining what the public perception is, and then why that's aspects of it are right, aspects of it might not be quite right, and then what the future might actually entail, and it ends with happiness, like good story. Like this is something that's good, because if it turns out that rockets are much cheaper and much more powerful than we previously thought, we can do much more exciting things.
So, I mean, so what do you see as the implications of this, if it works? And we're still, we're now just a couple of days after the Mark 1 blew its top off. There are some big unknowns still about whether or not we still don't know necessarily that this thing is going to be able to land in the way that it's intending. I mean, it's such a dangerous process to come back from low Earth orbit to re-enter the Earth's atmosphere, and it is a fairly different way to approach it than anyone has ever done this before. So we're still waiting to see if this even works. But let's just assume that the future versions do work, that they are able to kind of get this thing up and running, that it will be able to land. It is a fully reusable 2-stage rocket. What are the implications for carrying stuff to space?
Yeah, so I think it's fair to assume that given enough time, the team at SpaceX is extremely clever and extremely well motivated, and they will solve this problem, because really they've got a very clear vision for what the rocket should be able to do. And people have attempted, space models in an attempt to do this in the past. And the aim of the game is to increase the capacity and reduce the cost to launch things to orbit. So if we look at, say, the previous couple of years of launches, there's been on the order of, say, 500 tons of stuff launched to low Earth orbit a year. Now, if the Starship is able to do everything that Elon wants it to be able to do, which it's safe to assume eventually it will be able to do that sort of thing, then we might see a Starship launching 3 times a day. It's about 1,000 launches a year per Starship, and each launch 100 tons. So each Starship is able to move 100,000 tons to low Earth orbit per year. Now, how many Starships are there? Well, if they're able to weld them together outside, I mean, they might have to do some process improvement on the welding as we've seen. But to put that in context, Boeing produces something like 550 737s a year. Until quite recently was able to do it without making them crash. So it's not impossible to foresee a future where a Starship production essentially is not constrained, and you can produce as many of them as you need to. But if one is necessary, if one is enough to launch 100,000 tons to low Earth orbit in a year, that's enough to increase the total amount of mass to low Earth orbit by a factor of 200 over the current status quo, with all launches of all the different countries.
Right, like one Starship matches the launch capability on its own of all the rest of humanity by a factor of 200.
So yeah, one Starship launching 1,000 times in a year.
Yeah,
it's the same. Everyone else combined for a whole year. Yeah.
Right.
And so the sort of mass you're talking about starts to become kind of crazy. So in the immediate post-war era, a large cargo plane could move about 10 tons of cargo, such as in the Berlin airlift. And even now, like the total cargo mass that you can fit in a long-haul aircraft is on the order of 10 to 100 tons for a very, very large, say, military transport, something like that. But if you think about a container ship, say the world's largest container ships, can move like 20,000 20-foot equivalent units, each of which is on average about 12 tons or something like that. So that's almost 100,000 tons. So the largest container ships might be a factor of 2 or 3 more than that. So you're starting to say, well, the amount of cargo that a single starship could move in a year is equivalent to what a large container ship can move in a single voyage. So, I mean, there's several tens of thousands of container ships in the world, only a few hundred of the largest ones. And obviously their voyages take only a few weeks at a time. But you start to see that, if there were hundreds of starships, then the total amount of cargo being able to be moved from the surface of the Earth into low Earth orbit starts to be comparable to the total sort of cargo masses that, say, the Port of Long Beach might process. Or, at least in that same ballpark. It's not like a regional airport somewhere. It's more like a container ship port. And that's pretty exciting because at the end of the day, there's been a lot of ink spilled. You can go on Wikipedia and you can look up Mars exploration architectures, and there's about 100 different cases people have come up, and from Von Braun all the way through to Mars Direct through to the NASA Design Reference Mission. And all of them are essentially trying to solve this almost impossible problem, which is how do we get a handful of humans to Mars, keep them alive for a few years, and then get them back to Earth with dozens of tons of stuff, which is a very, very small number.
Yep.
I mean, like a well-organized camp at Burning Man can move more than dozens of tons of stuff. Ancient Egyptians routinely moved statues that weighed that or more with just human muscle power. And so it's an extremely harsh constraint that was so internalized by generations of engineers that no one really kind of allowed themselves to dare to think, what would it be like if, we could solve that problem? We'll just launch 1,000 SLSs. That's crazy talk.
Yeah.
You launch one, or two or something like that. And so, we've actually seen a lot of people take their favorite pet architectures and say, well, with a starship or two, I could, launch this twice as fast or with half the cost. It's like, no, think different. Okay. If you're flying, say, 100 starships simultaneously, you're flying 10 million tons of cargo low Earth orbit every year, and 90% of that is just fuel, which you need to get from there to wherever you're going. So you need a net million tons of cargo per year from the surface of the Earth into deep space, and say we'll send most of that to the moon and some of it to Mars. What can you do in 1 million tons a year? Well, that's a lot of cargo. Like, that's enough to really start digging some big holes and making some big,
right,
enclosures and mines and factories and monorails and all kinds of stuff.
And so, like, it is your position, I guess, in reading your writing that this hasn't really sunk in to many people. I mean, I think the people who are watching this, listening to this has occurred to them. Some people are skeptical, which is fine. We're still before this has all happened, but there's no reason, according to the laws of physics, why this couldn't be possible.
No, it's not impossible at all. And we can be reasonably confident that whatever form the Starship takes when it's able to do this, it won't look that much like the Mark I Starship. May it rest in peace. But the thing that will survive almost unchanged is the fundamental question which it's trying to answer, which is a fully and rapidly reusable spacecraft for transporting stuff to low Earth orbit and beyond. It'll be a 2-stage booster. It will have, essentially blunt body reentry characteristics. So it won't be a lifting body. It will have propulsive landing. It will use a high efficiency methane oxygen engine, most likely. And it will be essentially, once it's in production, the major constraint on launch mass to orbit might actually not be engine production rate or vehicle production rate, but rather launch site production rate. So how quickly can you pour concrete, down on the coast of Texas and Florida and anywhere else that kind of faces a bit of ocean where the sun rises, like facing east.
Right.
Somewhat close to the equator, although really it doesn't matter all that much.
So I guess the question, like, if you've got the ability to launch this much stuff, you're going to run, like, with the current launch manifest that is out there, you're going to run out pretty quickly. And in fact, SpaceX has already run across this problem. They've essentially, by reusing their first stage boosters, they're at the point now where they're waiting for, in many cases, the actual satellite payloads to be finished, and their in between plan is just start filling those rockets up with Starlinks and launching those instead while they wait for other payloads. So that's the second thing that you also went on at length about, was you also feel that people are sort of underestimating the potential for something like Starlink. Can we go into that?
Yeah. Well, I mean, I'm not an expert on the global launch market or anything like
You
that, but
did
I had heard
right.
around the traps that the
You
I
did the
had heard
math.
that SpaceX is
Yeah.
essentially. I did the math, yes, and I did, but I've also heard that SpaceX has run into the situation where they've, how to say that their production process is less terrible than the customer's production process, which means that the it's now a buyer's market rather than seller's market for launch, which is somewhat unusual. Normally, satellites sit around waiting for a rocket rather than the other way around. But this is not the end of the world. It turns out that of the global total industry in space, about $300 billion a year, about 3 billion of that, or 1%, is launch. 1 or 2% is launch, and SpaceX has done a pretty good job of essentially, if not taking over that market completely, then being in a position where it could do so with reasonably trivial effort. But $3 billion, any percentage of $3 billion is still a small number of billions, and Elon is really. I mean, I can't speak directly for him. He hasn't told me anything, but if you're trying to build a city on Mars, you need more than a small number of billions of dollars. So it has to think bigger. And something they realized, according to Gwynne Shotwell in 2013, was that their customers who are building these satellites, which normally cost hundreds of millions of dollars to build and launch and operate, were still operating at higher margins than the launch companies. So it's kind of neat because they can get into satellite production, leveraging their existing engineering skills and so on. And I don't think for a second that it's been easy, but it's not impossible. And they can build a product which does better than their primary product in a market that's somewhat less competitive, and at the same time, essentially become their own customer. Which, I mean, they didn't really have it, so it's good that their only option turned out to be a good one.
Yeah. And I mean, you ran the math that, for example, like with, say, the first stage is reused, you've got the cost of the fuel, you've got the cost of the fairing. You estimated $1 million for fairing, but they are reusing the fairing, so maybe you can remove that cost
once. Yeah.
Yeah, once. Well, it's a work in progress. There's the upper stage.
Yeah, it's work in progress.
You estimated $4 million for the upper stage, so they're looking at less than $10 million.
A lot of people think that's very optimistic.
Okay.
Yeah.
More,
yeah.
But let's say $10
Less
million.
than $10 million a launch.
Yeah.
But I think at the end of the day, so the Starlink launches on Falcon are a bridge, really. Like Starlink doesn't really become exciting until it's launched on Starship, at which point it goes from 60 satellites launched to 300 satellites per launch, and much higher rate. I think they can do some serious damage with just Falcon launches, but really to do the global internet for everyone, they'll have to use Starship.
Yeah, but everybody.
But yes, even with Falcon, they can totally crush the competition. It's not even close.
Yeah, and right, yeah. And you forget what you did the math that that within a couple of days they've paid back their launch costs and construction costs, and then they just start making money.
Yeah, I mean, so the only specific calculation I just did to order of magnitude. I didn't want to get more precise than that, because it's. If you try and get more precise than that, your blog post tends to date more quickly, as it in fact already has in some ways. But basically picking numbers that were both realistic and plausible, and found that the satellites could pay themselves off within weeks of launch, possibly a small number of months. And the interesting thing is that as the constellation gets bigger, that number actually gets smaller. So there's not diminishing returns. Essentially, there's quite a high cost to enter the market. That cost gradually diminishes and then continues to drop off quite quickly as the coverage kind of reaches full coverage.
But I mean, if they're able to pull this off, and they were able to, by your estimation, I guess they should be able to provide internet to the scale that they expect. The launch cost should be so low, and the construction costs of these satellites are so low that it's just a machine that'll print enormous amounts of money. When you consider the scale of the global telecommunications market, it is a many trillions market. and they stand to take an enormous chunk of it. Like no one can really compete against what they could be offering if they pull this
Yeah.
off.
Well, they're taking an enormous risk, obviously, and there's still plenty of what I'd call execution risk or mission risk that they face. I think there's a good chance they will prevail. I really hope they do. Maybe I'm biased because I believe in the mission, but and I think it's safe to assume that if it becomes as valuable as we hope, that the governments will line up to find ways to take a piece of the action.
Right.
But even then, as you know, essentially they won't to do. But even then, there should be enough to go around to really provide that river of gold or ocean of gold necessary to replicate industrial stack in deep space. And people, I think, I have a future blog post planned about this, but people generally underestimate just how hard it is to live at all on the moon, even for a couple of days, like in the Apollo missions, let alone live on the moon indefinitely or on Mars indefinitely, let alone do so, not like Antarctica where they have constant resupply, but in a way that where you're actually trying to build up mines and farms and things like that and fully industrialize. And when people think about this, they tend to think about the mythical American frontier history, wherein the rugged American pioneer kind of struggled west and ignoring all the genocide, with 20 acres and a mule was able to kind of be self-sufficient. And there are certainly environments on Earth that are more benign to human life than Midwest America, but there's certainly many that are far less benign. And so a good example I like to give people is, sure, a human can live more or less indefinitely in their pajamas on Hawaii or something, but take them 5 meters underwater and see how long they'll last there. And really, the surface of Mars, it's much nicer than the surface of the sun, but it's still a place that's an incredibly hostile environment for humans to survive, let alone, build a industry capable of producing anything that the United States can produce. We're talking millions, if not tens of millions of people, and I don't know enough about it to do the full design work, and I don't think anyone does. But it's a really, really big problem. It needs a lot of money.
Yeah, because you literally have to support every single thing that the human body requires. Like you extract almost nothing of value out of the environment apart from a little bit of mediocre gravity, some possible building materials, and sunlight. Like that's all you get, and everything else you are either having to create from scratch in a closed environment or scraping out of what you can find. So I'm setting this up here, and here comes the part where I think we may have a bit of a disagreement. But so we've got this incredible rocket that is capable of launching just a ludicrous amount of material Marsward. We've got a global internet system that is fountaining money that's going to pay for the whole process. But the goal is again, this is potentially what could happen as these two streams come together. But then the goal is, as stated by Elon Musk, is to settle Mars, settle the moon. They're awful places, right? Like they're just terrible.
Totally.
So does that make sense? I totally get that for people, there's this, as you said, there's this sort of this idea of sort of pushing the frontiers out and attempting to live in new places, but that gets old really quick when you can't breathe. So how do you feel about those as objectives for people to use all this money and all this launch capacity to actually attempt to live in places that are terrible?
It is a good question, and a lot of ink has been spilled fundamentally trying to answer the why question. And every now and then people talk about, we need a backup for humanity and so on. I've grown to think that's a pretty dark reason. But I think fundamentally it's about having an expansive future for humanity, which is basically the same argument, but with that happier twist on it. And I think that there's a bunch of really, really difficult problems to solve. But I would be very surprised if finding volunteers was the one that we got stuck with. There's always, people out there who really have a deep intention to go and do something and be part of history and to try and and test themselves. I know for my own part, when I was somewhat younger, I went out and did completely optional things that made no sense. We celebrate the exploits of mountain climbers and Antarctic explorers. And, it's still very competitive to get a job in Antarctica, for example. We have thousands, tens of thousands, millions of people worldwide who volunteer to be part of the armed forces, which is it's an act of kind of nation building service in a way. It's analogous in some ways, but at the same time also involves putting yourself in harm's way under someone else's command for really pretty small pay. I don't believe there'll be a shortage of volunteers. There'll be some challenges, obviously, managing aspects of scaling the organization in the early days, as any rapidly scaling organization has. But yeah, that'll be interesting to see. One of the things that I think a lot of people underestimate, they envision that people living on Mars will essentially be prisoners in a way, because they'll be working for no pay on Elon's luxury Club Med estate or something. And I think that's a slight misconception, because just the cost of getting people to Mars and keeping them alive there is so staggeringly high that anything that anyone can think of to reduce the demand on labor there will basically happen. So we're talking major automation and very advanced technology, but at the same time, we're also talking a strong premium for experts and specialists, just as there is in very, very high risk, high margin pursuits like oil rigs or stuff like that today. And so really it'll attract other relatively unattached, quick learning, ambitious, skilled people who are willing to take risks and get paid stupendous sums of money. It doesn't really matter how much you pay people to work on Mars. Early on, they won't have much to spend it on. Obviously they can bank it on Earth, and their family can spend it, or they can spend it when they get home. But the overall cost of keeping someone alive on Mars is so stupendously high that it doesn't matter if you pay them $1 million a year or $100 million a year. It just doesn't make any difference to the overall cost of the enterprise. So the sort of money we're talking about it would be described as quite motivational for most people who are in a position to essentially freelance their skills. But at the same time, money will tend to motivate people, but not beyond about 60 hours a week or something. So they also have to have a strong belief in the mission, which I think would be. I mean, we've probably been involved in things like this where it's kind of a strong team-based effort and people get together and you won.
I know it's late. I have to do the interview late. I'm doing a live interview right now. So if you want to be live on the internet.
I'm still in my taekwondo.
Okay. All right. Well, let me finish this. No, it's fine.
Same.
Yeah. There's my daughter.
Good day.
There we go. Hold on. There we go. All right. She just got her black belt.
Congratulations!
Yeah.
What thing?
I'm his daughter.
Yeah, she can't hear you.
He put his name on you.
Right. So, I mean, I think that's the part, and one of my friends, Cody from Cody's Lab, is watching right now.
Oh, great! I love that guy. I send him emails every now and then, but I think he's too busy to reply. He's so cool.
Well, there you go, Cody. You should talk to each other because if there are people who do really want to live on Mars, Cody's one of them, and he signed up for the Mars One project. He is testing out every single.
He's building a base in Nevada somewhere.
Yeah, exactly. Yeah, super fascinating. And so you're exactly right that there are people who, for them, this is absolutely one of the most fascinating things that they could do and totally worth doing for their lives. And I have mad respect for anyone who wants to do that, but I know it's absolutely not me. Right? I really enjoy Earth. I enjoy oceans. I like rivers. I like trees. And
how would you like to be part of building a new ocean?
I'll visit when it's done.
Well, that's fine. That's fine. And the thing is, as the population on Mars ramps up, obviously, the early days will be extremely tough, extremely pioneering, kind of out there types thing, the sort of stuff that Cody's into, right? And then over time, the creature comforts will increase. And I've got a plan in the future which talks about sort of how much area you need and why it's not enough to think about, essentially pressurized RVs and little domes and things. You have to sort of think about tenting tens of thousands of acres per year, and pressurizing it and having farms and factories and stuff all in shirt sleeves environment. And so over time, as the population ramps up, the creature comforts and amenities and so on will improve. And over time, maybe it will terraform the place and the atmosphere will be merely poisonous, but not enough of a vacuum to like blast your eyeballs out or something. But that's fine because over time, as it appeals to more and more people, it will need more and more people. And even if you never want to go, that's fine because there's roughly 10 billion humans, and we only need 1 million to go to Mars, maybe 2. And that's a very, very small fraction of the total number of people who even have advanced degrees. So,
and it also, part of it is like, it's sort of like when you think about, say, building the Great Pyramids of Giza, right? It was a monumental accomplishment by a nation state to be able to build something of that scale. But now with our modern technology, with our machinery, it would be a project, but there could be many of them built around the world if people set their minds to it and were willing to kick out a couple of, say, tens of millions of dollars and a bunch of construction equipment. They could build pyramids of Giza kind of anywhere they wanted.
You almost automate it, yeah.
Right? And so it's a factor of increasing infrastructure and technology and capability that makes what used to be a heroic accomplishment something that's more straightforward. And so it's, for me, it sort of feels like it's a question of when, right? When do you want to try to live on Mars? Do you want to do it when it's just barely possible? Like landing humans on the moon back in the Apollo 11, during the Apollo era, it was just barely possible. It took the entire resources of the US to be able to accomplish this. Now, Elon Musk is going to build Starship, and then maybe it's going to be able to make the trip and land, and people are going to do this, and it'll cost tens of millions of dollars, and they'll come back home and then say, we did it. And so that's possible. And you can imagine over time that setting up a city on Mars, setting up living in space, whatever it's going to be, there will be more and more infrastructure that these things aren't as crazy and just start becoming a natural, inexpensive, obvious thing to do next. And it's just a question of when people are going to want to accomplish it. And so it feels to me like it's farther down the road than a lot of people want. And I guess it's kind of then it's outside of our lifetimes, but kind of inevitable.
That's a bit sad. Yeah, I have to eat my greens and do some exercise so I live long enough.
And your third robot body, right? But as the energy needs of the world continue, as we acquire more and more of just the resources of the solar system, as we reach out farther and farther, and the growth of humanity just grows exponentially, it's just a matter of time before we've dismantled Mercury and built a Dyson sphere, and we're on our way to a Type 3 civilization. So
I don't know about that. We'll see.
Well, maybe. We've already begun the Dyson sphere, right? We've got a couple of spacecraft. They've got solar panels. It's already started. They're orbiting the sun, right? So,
well, the problem with the Dyson sphere is there's not enough matter in our solar system to build one.
Well, we'll get as far as we get, right?
Yeah.
We're just, we build the Dyson swarm, one solar collecting satellite at a time. But you also, there's some really exciting stuff that's on your blog, but there's a lot of concepts as well that you are less positive on. And there's a few I'd love to talk about why you think they're not going to happen.
Yeah, sure.
So one is beaming power from space.
Yeah.
Why is that a terrible idea?
Okay, so I'm guessing from the way we've started here that you've read and are an adherent to O'Neill's book, The High Frontier, which is a great book. And actually,
define adherent.
I don't know. Read it and think it's a good idea. I've read it fairly recently, actually, on the recommendation of a few colleagues, but and I have a review of it somewhere in the murky past of my blog where I talk about it. And it was a book that was written just before the space shuttle started flying. So it was kind of, in some ways, written in the same way that my blogs are written now, just before the Starship starts flying, and that really kind of grows out of the same hope, which is that in the very near future we will have essentially very, very cheap flight to low Earth orbit, and what can we do with that? And O'Neill got very excited by this idea of building cities in space with essentially rotating hollow spheres or cylinders, and he worked out ways of bootstrapping the construction using lunar materials and a whole bunch of other stuff that was super advanced in the 1970s. Very, very, very clever guy. He also invented a precursor to the GPS system. And he had a very, very interesting career. And actually, another connection to my own career, he worked on something that's a bit like the Hyperloop just before he died. So that was kind of crazy. But the question when you have to do this, as any kind of deep space settlement is, you say, well, does it make money or does it use money? And my view on this has always been, well, these things use money, and that's why Elon needs to get out ahead of everyone else and build Starlink and make squillions and squillions of dollars and spend it on this. But you say, oh, well, we don't have that ability. We need it to make money. Then you have to start constructing some kind of narrative in which going to space is worthwhile, financially speaking. And this is very hard to do because with a few narrow exceptions that I can get into, essentially everything that goes to space costs more money than it makes. And the exceptions are communication satellites and to some extent space tourism and some Earth observation stuff, which is pretty niche. And then obviously there's military uses of space, which is, they have blank check, but that's a different kind of story. And so O'Neill was essentially, like many others before him, had looked at this problem, and he decided the solution was, since mining stuff in space is difficult because it costs too much money to get the mass out there and bring it back, because moving mass around in space is extremely expensive. The solution was to create something of value and then send it to Earth using electromagnetic radiation, which is essentially what communication satellites do. They have data essentially encoded in microwaves, and value per bit or something is well, I don't know, it's like $1 per gigabit or something like that is the current cost of data down a high-speed internet line. But if you look at the amount of power actually needed to transmit a gigabit of data, it's a very, very small amount. It's in the tens of watts or something like that. It's a very, very small amount of electrical power. Whereas if you look at the cost of electricity on the Earth, which right now is somewhat less than 10 cents a kilowatt hour and falling fast thanks to solar power, and you translate that the same way, it works out that microwaves that are kind of chopped up with data are worth something like 1 billion times more than microwaves which are just blasting power. And so while it happens that you can put up a communication satellite and you can actually make money over time, if you just use that same architecture, which is solar panel generating power, making microwaves go down to the Earth, being received by essentially glorified antennas and then converted into power being used, it turns out that makes no money. And in fact, it's like off by a factor of 1 billion roughly or something like that. And you can look through my blog, and Max Fagan actually is a person who's done some incredibly detailed calculations on this, but essentially gets back to the same answer. And so it turns out that you can't make money. This is actually not a surprise. All good businesses take something where you can obtain it cheaply and sell it somewhere where you can sell it for more money. And the problem with power is that it's much more expensive to make it in space than it is to make it on Earth. And it's much, much cheaper to buy it on Earth than it is to buy it in space. So really, if you were in the business of transmitting power through space, you'd be better off transmitting power from the Earth to satellites in space that needed it than the other way around. That said, no one's going to try and do that because it turns out solar panels are essentially two-dimensional. They don't have a big mass penalty. So you can easily deploy almost arbitrarily large solar panels in space to power your space station or your communication satellite, whatever. And that's what people have been doing since forever. I think one of the things that generated the most controversy in that particular blog post where I talk about space power is not a thing, and then someone's like, you need to read all these articles by some people who've done some stuff, and I read through all the articles and they went into vast detail on how the widgets put together, and at the end of the day still didn't actually answer the question of how much money can it make and how much money does it cost.
Right.
Was that the cost of building the antenna on the surface of the Earth to receive the power from space is about maybe 80% of the cost of building a solar farm of equivalent power. So if you can think of some way of doing the antenna, which is basically just pieces of metal on the surface of the Earth, for 80% of the budget, and then 20% of the budget is allocated to building this giant space station thing, which no one's ever built before, and launching the whole thing into space and building it, maybe some automated robots to make it out of pieces of the moon or asteroids or something. But that's 20% of the budget.
Yeah.
And by the way, the solar power is getting 7% cheaper every year.
Right. So 1 year later, it's
time talking about
right.
It's quite obviously ludicrous.
Yeah.
Yeah,
so I think
ludicrous.
that's a fantastic way to really just judge all of this stuff, which is that either these things will make you money or these things will cost you money. And you can literally shuffle every single idea that's ever been presented into one of those two buckets.
Yeah.
Right.
My take is that anything that's interesting to me in space, which basically means building an industrialized civilization, like highly technological industrialized civilization in space. I'm not talking about, for one, I don't mean to get down on Cody, but he's a very, very clever guy, but I don't think people on Mars will be like forging their own metal or anything like that. They won't be using human power to solve these problems. They have to use mechanized and roboticized power to solve these problems. But that's going to cost a lot of money. Then the interesting question for me is, what's the least money it can cost, or what's the most you can do with a certain amount of money? So you can improve your cost efficiencies, but at the end of the day, it still costs money.
Yes, yes. And so the other idea that's been proposed is acquiring resources from space, going and finding just a single asteroid has $10 trillion of metals, precious metals in it, and you could bring it back to Earth and
The cocaine asteroid or something.
yeah, to destroy the economy with your one asteroid. So why is that not a good way to make money?
Well, I mean, imagine what would happen if you turned over a rock in your backyard and found an infinite platinum mine. And you're in a country where you got some money for that. In some countries like my native Australia, if you find a gold mine, the government owns it. Thank you very much. What happens is that because the cost of platinum is essentially set by the interaction of supply and demand, if you increase the supply infinitely, then the cost has to drop. That's just elasticity, price elasticity. And so it turns out that, if you say drop the price of platinum by a factor of 2, you may induce additional demand. But the overall size of that piece of the economy is unlikely to change by more than a factor of 2 or 3, at most a factor of 10. And the total worldwide size of the economy, which spends money on platinum, is less than $1 billion. So even if you found a platinum asteroid, the total cost of getting it, retrieving it, bringing it back to Earth, and all the rest of it, unless people discovered that platinum was something that they needed to eat every day or something, then the overall size of that segment of the economy which would use that would be unlikely to grow more than $1 billion. And platinum is a very interesting metal, and it's useful for all kinds of things. But because it's so expensive, it's not used much. Perhaps if it was much cheaper, people would use it more often. Would use it as a substitute for copper in electronics or something. But I mean, it's how do I put this? There's a lot of very interesting papers out there on asteroid mining and on mining the moon and so on. But the papers that do actually include like rigorous cost estimates always show that it's a terrible idea. And if you need any proof for this, just call up any mining executive that you might happen to know and ask them, does this look like a good prospect to you? Because these people have a very, very good nose for like what mining projects are likely to make money and not. And it turns out that even on the Earth, where essentially the workers can breathe air and there's a labor market that's available, and you just have to dig a hole, get the stuff out, put it through a machine that you can buy off from car to car and produce the stuff, most mines still only just barely make money.
Yes.
Because it's all marginal supply, right? So most of the mines are producing just, at fractions of a percent or whatever margin over their costs. And so, if you say, well, we want you to do all of that, but you also have to do it in a frigid, airless, radioactive vacuum that's three days by incredibly expensive, unreliable rocket ship from Earth, and there's no guaranteed market for it on return. And by the way, the technology doesn't exist yet. It's going to be like a $50 billion investment program to build the technology. I'm pretty sure they'll very quickly show you the door. Because at the end of the day, if we need more copper, we just have to dig a deeper hole on Earth. It's essentially infinite. The amount of material in the crust of the Earth is much, much more than the amount of material in the entire asteroid belt. Mm-hmm. So, and because of tectonic and geological processes, quite often the material in the Earth is concentrated. And yeah, there's a handful of elements which are relatively rare in the crust for whatever reason, but we still have a pretty good idea of where they are, and so I think we'll be much more likely to see, say, gold extracted from seawater than we are to see it extracted from mines on asteroids and things, unless there's actually a city being built on that asteroid and they need it to use it there,
right?
Not on the
Right. Well, and I guess that's the key then, is the in situ resource utilization, actually using the resources. It does make sense to use Martian regolith if you're going to build a base on Mars.
Absolutely. And that's because the cost of getting stuff from Earth to Mars is so high. And some people think that because, the same thing for the moon, essentially. And people say, well, there's water on the moon, we can sell the water because Earth is a place where water is notoriously scarce. To be blunt. I did the math on that a while ago, and I was unable to convince myself that it would always be cheaper to extract water from the moon, even if you're at the South Pole, than it would be just to ship it to the moon, with Starship or something like that. It depends on the volumes required and the amount of investment required. But the water on the surface of the moon, it's not like you just turn on a tap and there it is. It's kind of frozen stuff that's mixed in with mercury and other nasty stuff in the bottom of cryogenically cold craters that yeah, and again, you can look up fabulous papers that describe these very complex science fiction ways of getting it out, and I think it's very interesting, and I think people would try it if they were there. But I just think that if you needed a steady supply of water, and it turned out that building a rod well or something was quite hard, that you know, you would just call up
Right.
Elon or Jeff Bezos and be like, "Can you deliver it? Put it on
I'll take
NASA's
100
tab."
tons of
And they'll be
water,
like,
please.
"No worries."
Yeah. And it just shows up. But
Exactly,
now,
exactly. And you'd have to have it anyway. You'd have to have a guaranteed supply chain anyway. So there would have to be a mechanism for getting anything you needed on the surface of the moon or Mars from Earth. It's just over time, you would do what you could to get it locally if you needed it. And the main reason you need to get water on Mars actually is to produce rocket fuel to fly back. And so that's more than you can ship there realistically.
now you do have some good news.
Realistically.
Realistically, yeah. Which is that
course.
you don't think that radiation in space is as bad as everyone is concerned. So why are you I guess more sanguine about the potential for radiation in space?
Yeah. So, I mean, people will point at me and say, "Well, you're a theoretical physicist, you're not a radiation physicist," and I freely concede that. I've merely read papers on the subject and can do the math, but
There's some
kind of
particle
long and short of it
physics
is that for a long time this
involved
was almost a
in,
religious argument.
there's some particle physics
I
involved in
was
getting a
actually taught
theoretical physicist.
radiation physics in Australia by a guy who defected from Persia after the coup there or whatever it was in the 1980. So, part of the reason that I struggled to get to build an atomic bomb is that the people who knew how to do it left and came to Australia and other places and taught me not how to build a bomb, but how to do this sort of calculation. So we actually flew an instrument, and I mean, not me personally, NASA flew an instrument on the last rover, which went to Mars, that measures the radiation that a human would receive. And it turns out that, as people knew, when you're in deep space, if there's a coronal mass ejection or a solar flare, you can get basically a fatal dose if you're not shielded, which is bad news. But you can build a reasonably small radiation shielded area of the spaceship with a few inches of water or something like that, and you'll be okay. But once you're on the surface of Mars, you actually have a bit of shielding from the planet itself and then from the atmosphere, which, although it's thin, is not entirely useless. And the total amount of radiation that you could expect on the surface of Mars is about 200 millisieverts a year, which is a lot more than what you get on Earth in most places, unless you were getting regular medical X-rays or something. But there are actually a few places on Earth where the natural background radiation is that high or nearly that high. And we don't have a strong statistical signal that it's bad for you. There's been hundreds and hundreds of studies, and some have shown slightly increased risk of certain kinds of cancers if you're a young, like a child or something, and some have shown no increased risk. But excuse me, a lot of these studies, or similar studies, have shown that if you smoke or if you drink a lot of alcohol, if you live by a freeway or you stay up late at night, talking to friends on the internet or something like that, then you have much increased risk of premature death due to cancer and other lifestyle-related diseases.
Right.
In particular, if you're very overweight or you eat a lot of hamburgers or something. So you would expect that, if you're exposed to a lot of radiation, that you would have a slightly increased statistical risk of getting cancer. And I think it's probably fair to say that if you had a large population of Mars, all taking 200 millisieverts a year, then yes, the risk of cancer would be incrementally increased, but the risk of dying of other things also increases. So it kind of evens out. Sorry.
Yeah. Do you need to grab some more water? Did you want to grab some more water?
I'm going to take two if that's okay.
Yeah, no problem. Yeah. So let me see here. I see a couple of questions there while Casey grabs some water. So Brandon Frazier says, Frazier, can they run a high voltage current through Starship's hull and help create a barrier from radiation with the magnetic field that it would create? I actually did a whole video all about the possibility of building an artificial magnetosphere around a spaceship. And the gist of it, I mean, both NASA and the European Space Agency has really tried to be able to do that. And so far, they haven't been able to create one that is more economical than just having a lot of water. So just protons, just having a lot of protons between you and space currently is the most efficient way to be able to get this done, and very reliable, right? Which is that you just have a good shielding. If there is a coronal mass ejection, you just build a fort and you just hide in the middle of it and wait till the storm is over. So
It's like
So
grab yourself a
definitely,
bread and
yeah. I
bake
mean,
things.
like literally for 50 years, like it definitely has occurred to NASA, and they have papers that they wrote 50 years ago about proposing some ways that they could do an artificial magnetosphere, and still nobody has been able to crack the code to be able to do that.
The
So
problem
Dylan
there is the fact
O'Donnell
that it's so heavy.
is in the chat right now out of Australia, and he says that your sister is going to be speaking at the 2020 Star Stuff conference in Australia.
Yeah,
Annie
well, she's
Hammer.
been doing great work recently. She has a podcast called Space Junk, so you should all check it out.
Yeah, that's awesome. Yeah, I was at the one in 2018, and it was a lot of fun. So, and a probably easier trip to get there from Australia than to come from unless she's not living in Australia still. But
She travels a lot actually, but she lives in Australia. So.
yeah, yeah. So I got a couple of questions here in the last 10 minutes. Are you doing okay? I mean, we can wrap this up if you're losing your voice. I
I'll be okay.
You're
I
gonna
just
be all
feel
right. Okay, all right. I
yes,
will.
yeah.
So it's a couple. Arjun is asking, are those a bunch of rocket ships behind you? And so yeah, yeah. Let's. So what do you got behind you there?
It's a picture at launch of every single rocket flight from the United States that took humans into space. So that includes the Mercury flights, the Gemini, Apollo, Space Shuttle, Spaceship One.
Yeah. There's like one. You can see in his just over his shoulder. Or you can see now. There it is. Yeah. So you got Spaceship One there. Yeah. And then all of those shuttles. And I think I see some X. I see like
Oh
the
yeah, there's
X-15 up
X-15
there.
as well, yeah.
Yeah. Yeah.
Yeah, that
So
was a fun afternoon putting all those pictures together. I have a version with all the metadata as well.
that's amazing. Have you seen someone did people have done like a synchronized shot of like a whole bunch of space shuttles all launching at the same time, day and night, and yeah, it's pretty great. And that's just the ones that have launched from the United States. So I can just imagine if you add the ones that have launched
Yeah,
from Russia, the ones that have launched from China, like that's a big
yeah. So
wall.
I have a version of just China's 6 launches, and Russia's about 190. But actually, there aren't public photos of about 6 of Russia's launches or Soviet Union launches. So I haven't completed that poster yet. If anyone knows where to find photos of very early classified Soviet crewed launches to space, please let me know because I'm trying to complete that poster for like 3 years now.
Right.
Yeah.
I mean, is it going to take a trip to Russia to Star City? It's
I don't even know if photos exist, to be honest.
oh, it's yeah.
I mean, maybe. I've asked around and I haven't heard anything. So,
So let's get a couple more questions here. So Brendan Fraser asks, see, it's very hard for me to say the word Fraser because, I say Fraser. Would Starlink be able to communicate interplanetary with the addition of simple relay satellites to connect the network? So do you see Starlink being able to assist with interplanetary communications?
yeah, for sure. One of the things that I'm very excited about trying with Starlink is to build a distributed antenna with it. Obviously, I don't get to do that myself, but maybe someone listening to this will be like, that sounds like a cool idea. I'll put in some software that does it. And then, obviously with that antenna, the wider it is, the better. And the Earth is very wide, so you can do a very directed beam.
So when
And
you say directed antenna, like, can you what would you want to do here? I don't understand.
radio astronomy and deep space network communication, talking to Voyager or something like that.
So like
And
make your own Event Horizon telescope out of Starlinks.
yeah, essentially, but in the radio. You could do a radar tracking of asteroids and investigation of, say, Venus's atmosphere or something like that. So all kinds of cool things.
Just with a distributed network of
Yeah,
satellites orbiting around the
yeah.
Earth with. Well, I mean, one of the things
Good
that
software defined radio on there.
yeah, I mean, one of the things that a future generation of the Starlinks, they're going to be able to actually put payloads on these things, so they'll do their main job of being able to provide communications for the Earth, but there will be room theoretically for payload for space telescopes and things like that, and maybe that'll be one of the ways that Elon Musk will try to reduce some of the ire of astronomers who've lost pieces of their night sky.
of their night sky. Yeah.
Yeah.
Um, yeah, maybe we'll see. I don't know if Starlink satellite's the best platform for space telescopes.
No, no,
The
and yeah, having telescopes
Starships
that
would
are
be a pretty
moving
big one.
with different baselines all the time, that wouldn't really give a lot of value there. So, um,
Yeah, I just think painting them black would probably be a good approach.
yeah, yeah, yeah. Well, I thought,
Double
I
management
mean,
again.
he said that they were going to look into painting them black for the next launch, and I'd heard that they might have already done that with the second launch, but there's no way around the actual solar panels. So,
Yeah, I mean, yes and no. There are tricks you can play. At the end of the day, the satellites, when they're in the Earth's penumbra, will always have some albedo.
yeah,
The good news is that if you're at a equatorial observing site, then when astronomical twilight, essentially all the satellites will set at about that point, and so you will still have that blessed 7 or 8 hour window in which you can observe without asteroids, without satellites being a problem. Of course, if planes are flying over, it's still
yeah.
the same issue. But yeah, we're going to have to get smart about how astronomers and Starlink and everyone else shares this resource. So
Yeah, well, and where I am, we see satellites all the time because I'm at a more northern latitude, and so
especially in summer, the sun essentially doesn't really set if you're in the upper atmosphere.
yeah, exactly. And so we'll see satellites. You know, we see the International Space Station fly overhead and watch its full pass, and then 90 minutes later we watch it again. And then 90 minutes later we watch it again. So it's in the summer, exactly when you get those full passes, it's quite a thing. And I've definitely had I've had the ISS, do a photobomb through one of my photos.
And I'm sure Dylan O'Connell will have plenty to say about that. But
Yeah. Well,
Chris
Dylan,
Hadfield's just like shooting overhead, being like playing his guitar, and like 90 minutes later, he's still playing his guitar.
yeah, Dylan takes shots of like the one that I really love. He took a photograph of the Rosette Nebula, and it had a bunch of actual geosynchronous satellites just slowly dawdling their way through his photographs. So
Yeah.
and then he has to remove them. So he's very well aware of how to do that.
If you look closely, you can find unusual things out there, the various classified satellites and so on. But if you've got a big enough telescope, you can actually see them and be like, wow, that's really big.
Yeah, exactly. Living Creature asks, what kind of security do they have in place? Is hacking? I mean, what do you think about the potential for someone to hack? I mean, their computers, they're hackable, right?
Yeah. I'm sure that they're strong targets, like big targets.
Yeah.
But I think that Planet Elon has quite a lot of production experience and that sort of thing, because the Teslas are also kind of in that ballpark, a big soft target, big juicy target essentially, and they've been. You can go on YouTube and find videos about people who've hacked their Teslas one way or another, and Tesla's been pretty responsive about pushing out software updates there. So I think that you can see some half-hearted attempts to do the same thing with Starlink, but I suspect that they have as much chance as anyone of not being totally pwned. I hope.
I mean, you do need certain kinds of capability to be able to send a directed signal to a satellite as it's passing overhead. I mean, it's a little more complicated technically than walking up and trying to clone a key fob for someone's Model S. So,
Well, I mean, everyone who has a Starlink subscription will have an antenna that can communicate with that satellite. The question is, how well siloed are the instruments versus the communications router part versus the satellite operations part. I suspect that Tesla will at least encrypt the connection. I hope. We'll find out.
We've reached the end of our hour, and I know you are. It's time for bed for all of us. It's so late. I'm never up this late. But Casey, thank you so much for taking the time to chat with me today. That was super fun. And I think I've really, really enjoyed your writing. So please don't stop, and definitely continue to both provide, sort of beyond anyone's wildest optimistic expectations, and at the same time dunking on people's sci-fi dreams. I think both are really valuable, and I've really been enjoying it. So we'll put a link to your blog here as well as some of your other work. And what's the
You can find me on
best
Twitter.
way if a person wants to follow you? Go to the blog, see what you're doing there.
If you want to just interact with me, probably find me on Twitter is the easiest way. I also get emails and stuff. My email address is not hard to find, but
Yeah.
but I prefer if you've got a good question, just put it on the blog or put it on Twitter, because then other people can see the answer to it as well.
Great.
It's just good. Yeah, and I'm going to try and be optimistic, even in my pessimistic posts. There's always going to be like a note of optimism.
Yeah. No. The longer I do this, the more realistic I've become. But I definitely still try to bring the optimism, and I'm still as fascinated and excited and hopeful about what humankind is doing for the future of space flight as I've ever been. But and especially now that I understand the nitty gritty details, I'm as excited as ever. So, Casey, super fun. I'm really looking forward to everything else you do into the future, and hopefully we'll come back and have you come talk to us again sometime.
Yeah, if someone else ever reads my blog ever again, that would be fun.
I'm sure it'll happen. Yeah, just say SpaceX whatever, and then people will show up. All right.
All right.
Thanks a lot.
Thank you.